I'd like to walk you through an example or two of finding unknown measurements with or for similar polygons. In this example that I have on the screen, we have two what appear to be trapezoids. Uh, we're told they are similar, and we have one pair of corresponding side lengths. We have the perimeter of one, and we have the area of the other, and we're asked to find the missing values, the area of the larger trapezoid and the perimeter of the smaller trapezoid. So what we need to remember in this case is that for similar polygons, the side length, corresponding side length ratios and the corresponding uh, and the perimeter ratios are equal, and that the area ratio for similar polygons is the square of the side length ratios. That means if I have the ratio of areas of two similar polygons, if I take the square root of them, I have the side length ratios. If I have this corresponding side length ratios and I square them, I have a ratio of the areas. That doesn't mean it's the actual areas, but it is a ratio of the areas. So in this example, I've got a side length ratio of 21 to 8. So if I square 21 and I square 8, I've got 441 over 64. Okay, that is an area ratio. That means for every 441, and they don't give us units here, for every 441 square units in this polygon, I have 64 square units in this one. And again, that may not be the actual, but that is the ratio. So let's first look at finding the perimeter of the smaller trapezoid. So remember, the perimeter trapezoid, or the side length ratio is equal to the perimeter ratio. So I can set up my side length ratio 21 to 8 and set it equal to a ratio of perimeters. I have one perimeter, 189. Notice I'm building my ratio in the same order, large over small, large over small. And so now I'm just looking for P, the perimeter that make the number, the value that goes here that makes this ratio equal to this one. So when I cross multiply, remember the cross products of proportions are equal. When I cross multiply the diagonal that has a number in both spots and divide by the other number, that's the pattern if you follow the algebra rules, I get 72. So that's the perimeter of the smaller, what we're calling trapezoid. Now, what about the area? We've already have an area ratio for every 441 square feet in one, we have 64 square feet in another. So let's set that equal to the ratio with an actual area in it. So this ratio should equal this one. What's the number that goes here that makes this ratio equal to this one? And since this is the ratio of actual areas, this will give us our actual area. So I cross multiply and I divide, and I end up with 2,205 square units. Again, I took the side length ratio, squared it to make an area ratio, and set it equal to the ratio of the actual areas. And that allowed me to find the actual area of the larger trapezoid. Okay, hope that helps.